Hi everyone, welcome back to our math lesson. Today we're going to learn something that will make algebra much easier, how to generate equivalent expressions.
Welcome to our 7th grade math lesson on generating equivalent expressions. Today, we'll unlock some fundamental algebraic concepts that are essential for your mathematical journey. By the end of this lesson, you'll be equipped with powerful tools to work with algebraic expressions in different forms. These skills form the foundation for solving more complex equations and real-world problems. Specifically, you will understand equivalence, recognizing that expressions can look different but represent the same value. Apply the distributive property to expand expressions and create equivalent forms. Combine like terms to simplify expressions by adding or subtracting similar variables. We'll also learn to expand and factor, transforming between these forms strategically. And finally, you'll be able to explain your reasoning, justifying why different expressions are mathematically equivalent. So, what does equivalent mean in mathematics? It means having the same value, even when things look different on the surface. Think of it like having different ways to say the same thing. They might use different words, but the meaning stays the same. For example, 3 plus 4 and 7 are equivalent because they both equal 7. Similarly, 2 multiplied by 5 and 10 are equivalent, as are 15 divided by 3 and 5. Now, let's extend this powerful idea to algebraic expressions that contain variables. Let's look at equivalent expressions with variables. For example, 3x plus 4x is equivalent to 7x. How do we know? If x equals 2, then 3x plus 4x becomes 3 times 2 plus 4 times 2, which is 6 plus 8, equaling 14, and 7x becomes 7 times 2, which is also 14. Both give us the same answer. You can think of it like this: if you have 3 apples plus 4 apples, you have 7 apples total. Similarly, 3x plus 4x equals 7x. The form changes, but the value stays constant. One of the most powerful tools for generating equivalent expressions is the distributive property. The formula states that a times b plus c equals a times b plus a times c. It's like a mathematical multiplier that spreads a number across terms inside parentheses. Here's how it works. You distribute, or multiply, the outside term to each term inside the parentheses, then add the results together. For example, starting with the grouped form 3 times x plus 5, you distribute the 3 to both x and 5, giving you 3 times x plus 3 times 5. Finally, you simplify to get 3x plus 15. A pro tip: think of the number outside the parentheses as being distributed to everyone inside each term gets its share. Let's work through some guided examples of distribution. For problem 1, 2 times 4 plus y, first, you distribute the 2, so it becomes 2 times 4 plus 2 times y. Then, simplify to get 8 plus 2 times y. For problem 2, 5 times 3 plus x, you distribute the 5, making it 5 times 3 plus 5 times x. Simplify, and you get 15 plus 5x. Notice how the parentheses opened up and each term inside got multiplied by the outside number. Both the original and expanded forms are equivalent expressions. Next, let's talk about combining like terms. What are like terms? They are terms that have the exact same variable raised to the same power. Think of them as the same type of mathematical object that can be combined. For instance, 4x and 2x are like terms because both have the variable x. 5 times y squared and 3 times y squared are like terms since both have y squared. And 3 and 7 are like terms because they are both constants. However, 2x and 3 times y are not like terms because they have different variables. To combine them, you simply add or subtract the coefficients, the numbers in front, while keeping the variable part the same. First, identify like terms by finding terms with matching variables. Second, add or subtract their coefficients. And third, keep the variable, writing the result with that variable. For example, 4x plus 2x equals 6x. And in a slightly more complex example, 5 times y plus 2 times y plus 3 plus 7 equals 7 times y plus 10. Now it's your turn to practice combining like terms. Remember to identify like terms first, then add or subtract their coefficients. Let's look at problem 1. 7a plus 3a. Both terms have the variable a, so we add the coefficients. 7 plus 3 equals 10. The answer is 10a. For problem 2, 2x plus 5 plus 4x. Here, the like terms are 2x and 4x. Combining them gives us 6x. Then, we add the constant 5, so the answer is 6x plus 5. Finally, for problem 3, 9 times y plus 2 plus 3 times y plus 4. We combine the y terms. 9 times y plus 3 times y equals 12 times y. And we combine the constants. 2 plus 4 equals 6. So, the answer is 12 times y plus 6. Understanding when to expand or factor is like knowing when to zoom in or zoom out on a map. Both views show the same place, but each is useful for different purposes. Expanding makes expressions longer by using the distributive property. For example, changing 4 times 2 plus x into 8 plus 4x. Factoring, conversely, makes expressions shorter by pulling out common factors, transforming 8 plus 4x back into 4 times 2 plus x. The key insight here is that both 4 times 2 plus x and 8 plus 4x are completely equivalent. They represent the exact same value for any value of x. The form you choose simply depends on what you need to do next in your problem. Choosing between expanded and factored forms is a strategic decision. Each form has specific advantages depending on what mathematical task you're trying to accomplish. Expanding is great for simplifying complex expressions, combining like terms, seeing all individual parts clearly, and substituting values into expressions. Factoring, on the other hand, is great for solving equations efficiently, finding common factors, making expressions more compact, and identifying patterns and relationships. The best mathematicians know how to switch between forms flexibly, choosing the representation that makes their current problem easiest to solve. Let's see how equivalent expressions show up in everyday situations. Imagine you're buying school supplies online. The scenario is that you're ordering notebooks that cost $3 each, plus a $5 shipping fee. How can we represent the total cost? There are multiple equivalent forms. Form 1, the expanded form, is 3x plus 5. This clearly shows the cost per notebook as 3x and the shipping as 5 separately. Form 2, a partial factored form, is 1 times 3x plus 5, which simply shows there's one order containing everything. And Form 3, an alternative factoring, is 3 times x plus 5 over 3. This factors out the price per item and is less common, but still equivalent. All three expressions give you the exact same total cost for any number of notebooks, x. The most practical form here is typically 3x plus 5, because it clearly shows the per item cost and the fixed shipping fee. Let's summarize our key takeaways. Remember, equivalent expressions have the same value. They might look different, but they represent identical quantities for any variable value. Use the distributive property to expand by multiplying the outside term by each term inside parentheses. A times b plus c equals a times b plus a times c. Combine like terms to simplify by adding or subtracting coefficients of terms with matching variables and exponents. Factor to create more compact expressions by pulling out common factors to make expressions shorter and often easier to work with. And finally, these skills solve real-world problems. From shopping to construction, equivalent expressions help us model and solve practical situations. Let's do a quick check with an exit ticket. I'll give you an expression, and you try to match it to its equivalent form. Expression A is 6 times x plus 2, expression B is 4x plus 3x, and expression C is 10 plus 5 times y. Now, here are your choices. Choice 1 is 7x, choice 2 is 6x plus 12, and choice 3 is 5 times y plus 2. Pause the video if you need more time. Alright, let's reveal the answers. Expression A, 6 times x plus 2, matches with choice 2, which is 6x plus 12, using distribution. Expression B, 4x plus 3x, matches with choice 1, 7x, by combining like terms. And expression C, 10 plus 5 times y, matches with choice 3, 5 times y plus 2, by factoring. Congratulations! You've mastered the fundamentals of generating equivalent expressions. You can now expand, factor, combine like terms, and transform expressions with confidence. In our next lesson, we'll dive deeper into choosing the best form of an expression for different problem-solving situations. You'll learn strategic decision-making skills to become even more efficient at algebra. Here's a sneak peek challenge. Which form would be easier to solve? 3x plus 15 equals 0, or 3 times x plus 5 equals 0? Think about it, and we'll explore the answer together next time. Keep practicing, because the more you work with equivalent expressions, the more natural these transformations will become. Great job today!